During a review of the tool, a few things were noticed as needing a change. During that review, we used a LogoPress function called assembly color/transparency. And we were able to, using these sliders, make the tool opaque. Changing the appearance to being opaque, we can people who are not familiar with the tool makes this visibility easier to look at. The designer, on the other hand, would most likely want to look inside the tool, and he would be able to see what he's looking at because he is familiar with the design. The first thing that was noticed was that when we change the progression of the tool, the form punch is now breaking out of its retainer plate. So I'm going to select Tool Structure and select the plate I would like to adjust. I will first adjust this retainer plate and make it a little bit shorter. I'll reduce it by a ½ inch. Then I'll select the other retainer plate and add a ½ inch. We can now see that we have enough room here that the form punch is now being retained fully in that retainer plate. I'll now exit out of Tool Structure, and we can see that this shoulder bolt needs to be moved. These two, this one and this one. So I'll just select that shoulder bolt and select Edit Positioning Sketch. It puts me into the positioning sketch. It makes me normal to it. And I'm just going to adjust these two values, dimensional values. Subtract a ½ inch from each one of these. And exit the positioning sketch. The position of the screws are now adjusted. I will also need to adjust some of these springs, the location of some of these springs, because of the progression change also. I'll just click on one of these and select Edit Positioning Sketch again. Puts me into that sketch, and I'll just drag these 2 points over by a little bit. Of course, we can fully define these if we would like. And I will look to see if the position of any other springs need adjusting. I'll just adjust this one over a little bit and exit the sketch. The next item that we notice needed changing is that the wire EM start holes for these 2 punches need to be repositioned. I'll just select on the wire EM start hole and find it in the tree. If I hover over it, we can see that the positioning sketch is actually being referenced into the lower assembly. So I'll expand that. And right here is the positioning sketch. I'll select it And I'll select LogoPress 3 Edit Positioning Sketch. And I can see that I selected the wrong one. This one is actually in the middle assembly. I'm now in the positioning sketch. I'll drag that over. Of course, again, I could define the location of this if I'd like to. Next, I'm going to position this one. This one is actually, the positioning sketch for this is in the lower. There it is. I'll select it. Select Edit Positioning Sketch. And I'll just drag that over. So now both of those wire start holes are repositioned to be within the openings in the plates. Another thing that was noticed that needed to be added is that the die openings for the pierce punches are being wired in with land and taper. It was noted that we would like to have die buttons in there. So to edit those, we can either select on the punch or any hole associated with that axis of that component axis, in this case the die opening, and select Standard Component Library to edit it. We can see the preview of that punch. And under the die plate, I just select Choose Another Standard Component and select what style of die button I would like. Then, at this point, I can choose the size of that component. So I want a VNX 50, meaning half-inch diameter, 1.25 inches long. Then I'll select in other plates cross through the die shoe and adjust the slug opening. I'll just right click on it, go to standard drills and select my standard drill size. Click OK. It puts me into the positioning sketch. I have 2 sketch points, which are already placed. They're coincident with the punches in the strip. So I will just exit out of the sketch and it'll add those new components and holes. We can see now we have die buttons in here. I'm also going to adjust it for the pierced holes in the part. We can see that's for these 2 holes. So I select on the inside wall of that hole, select Standard Component Library. Puts me into editing it. Show the rest of the tool using my LogoPress filters. Scroll down, select what type of die button I would like. This time I want a VNX 62 inch and a quarter long. Go to other plates cross through, select my shoe, right click standard drills, and select the nearest standard drill size. Click OK, puts me into positioning sketch. I do not need to change that. I'll just exit out of the sketch. And now we can see we have buttons in those two locations also. Now that I have buttons in here, I noticed that these holes, this button is too close to the die opening. And also over here for the pilot hole, this is really close to this die opening. So I'm going to move each one of these in closer to the center. These are for the pilot holes. To do that, since these were placed coincident with the center of the punches in the strip, I'm going to make that change in the strip assembly. I'll open up the strip assembly. Here's my two punches. I'll go into LogoPress 3, create, edit a strip layout. Select one of the punches. Select edit the sketch of the selected punch. And I just need to change this dimension. Reduce it. I'll just bring it in 1/8 inch and exit the sketch. I'll do the same to this punch. Apply that change. Exit out of the strip layout. Select yes to update the information note. Save the strip assembly and exit to go back to the tool assembly. Do a couple of rebuilds. You can see the position of those holes have changed throughout. If I show the strip, you can see all the holes have moved in. And if I show the upper half of the tool, those also have changed so that they are, the punches and pilots have moved in along with the holes in the strip. Another item that was noticed that needed changing is that these ejector pin holes are barely catching where the slug would be. So I'm going to move those in. So I'll just select on the inside of that hole and select Edit Positioning Sketch. Puts me into Positioning Sketch, and I'll just change these two dimensions. We can now see that we are now catching the slug. I will now add heels on these two notching punches. I will do that in the strip assembly. So I'll open up that strip assembly again. And I'll add heels onto these two punches using the LogoPress 3 shoulder heel pedestal roof function. I want to add a heel. type of heel I want to add is this one, heel with fillet inch. I select my reference face. I could adjust the size of it using these values, but this is what I want. So I'll select OK. I'll add the heel on this punch. I'll save the strip assembly, exit out to return to the tool. And now you can see there are heels on these two punches, because these punches are derived from the punches in the strip assembly. Now that I have heels on these punches, on the die half, I would like to reduce the clearance around the back edge of those heels. So I'm going to open up the die block and just click on the inside opening of that, one of the openings, inside face of one of the openings, and select Edit Sketch. Normal to without zooming out. I'll select these 5 sketch entities to offset them in. Do not want to select the chain, reverse the direction. And you can see here we have 5 thousandths clearance, so I want to offset that in 4 thousandths. I'll just draw in a transition, dimension that transition line. And then trim to it. I only then need to make that old geometry construction and exit the sketch. I'll do the same thing to this opening, die opening right here. Need to reverse the direction. Need to dimension this. Now those openings have reduced clearance around the heel. I would also like to point out, in addition to the SolidWorks or the LogoPress tool animation and dynamic interference detection, you should also run the SolidWorks interference detection. LogoPress will, the dynamic interference detection will catch interferences between items in the different assemblies that are moving dynamically in between each other. Whereas the SolidWorks interference detection will check for static interference with items within the same assembly. To run the SolidWorks interference detection, you just go to Tools and select Interference Detection. Right now you can see it's checking for interferences within the entire tool. I'm going to clear that out, and it is better just to select the individual sub-assemblies, lower, middle, and upper. I'll select the lower and then calculate. You can see I found all of these interferences right here. I'm going to select the option Treat Non-Interfering Components to be Hidden. And here you can see we got an interference with a fine thread screw cap with the shoe. And you can see here, that is what I'm within all of these interferences right here. This particular interference is the lifter pin interfering with the shoe. So you can see what is happening here is the holes are not in the die shoe at the moment. So we'll have to check on that once we return and exit out of the interference detection. Here we can see this is just the interference with the fastener with the cosmetic threads. There is an option in SolidWorks called Create Matching Cosmetic Threads folder. If I check that, you can see it creates a folder right here, and it would normally put all of the fasteners that have interferences with cosmetic threads into that folder. But there is currently a bug within SolidWorks that this only works with metric fasteners and cosmetic threads. The inch components is currently not working. So currently you would just have to go through these items, and if you find one, right click on it and hit ignore. I'll exit out interference detection, and I'll check out those holes right here. You can see they are not visible. So I'm going to click on the shoe, expand it. If I scroll down, I can see it's just that one of the features is suppressed. It got suppressed accidentally. I unsuppress it, and now you can see the holes are there. Another thing that I did notice when doing the interference detection are that the holes for these dowel pins are incorrect. So I am going to click on the dowel pin, select Standard Component Library, put focus on the slip fit plate, clear that out, and reselect it. Now I got a nice through hole. Exit out. I don't need to adjust the location, so I'll just exit the sketch, and those holes are corrected. I also notice that these two screws here should be counterbored in, so I'm going to select that. Standard Component Library. For the head plate, I'll change the hole type to a counterbore hole. The length of the screw automatically adjusted. Exit out of sketch. The old screw will be removed and the new one put in. When looking at the lifters, I notice we don't have a nice dome shape on top of the lifters. So I'm going to add those right now. Click on one of those and open it up. I'm just going to edit the revolve of that. of the sketch. And I'm just going to add that dome shape. Couple of dimensions. Now we have a nice dome shape on our lifter. Save that, close. Double check all of them. Now these lifters were put in with a separate insertion, so I just simply need to take and use the SolidWorks replace command and replace them with this particular lifter. They are all should be all the same going all the way through the die. So I'm going to select one of these, this one, and say I want to replace them with this pin right here. Make sure you have your match name and reattach mate selected. You get a preview of that change. Everything looks good. I don't need to reverse any mates or flip any mates or anything, so I'll just check OK. Since I altered that lifter pin, I'm going to create a drawing for it. I could do that just by opening it up and using SolidWorks to create a drawing, but I'll show you a LogoPress function called automatic drawing creation. In here, I can make drawings for one or several items within the tool assembly. Anything that is highlighted green, like these right here, what that means is it already has a drawing associated with it. Anything that is not highlighted green does not have a drawing associated with it. It would check everything else that would need a drawing. Well, it doesn't consider anything that's purchased needing a drawing. But in the case of these lifter pins, since they are being altered beyond the purchased item, we will create a drawing for that. I'll just check the royal pin. And then I just have to select what drawing template I would like to use. I'll just use the A part one. And then I just have to select what format do I want to use. And then check OK. And there you can see it automatically created that drawing according to the template I had chosen. I'll just right click on it, select open drawing. There it is. I just need to, and you can see that it automatically filled in the title block for me, including the customer, tool description, and so forth. So I just need to add a couple of dimensions here as to what I need to alter on here. The overall length, and Also this radius. And this height. I can then save the drawing and close it. I'll also show you that these other drawings have also updated automatically because of the parametrics of SolidWorks. I'll just click on this die block and select Open Drawing. Because something had changed, it is asking me if I want to update the whole table. I'll say yes. The whole table just updated. And you can see that the reduced clearance is now on the opening. The position and size of the die buttons. We got die buttons here now. So these were just wired openings with land and taper. Well, those are now adjusted and have new call outs on them, H and P. So I will just come over here. See, press fit for die button. I'll now open up one of the drawings for one of the plates that had changed. We had changed the length of these retainer plates. So I'll just open up the drawing for that. It is asking me to update the whole table because, well, things had changed in that block. So I'll say yes. And you can see I'll select yes. Table updates. And you see the new location of the wire starts and that the retainer plate is now longer. I can also open up this retainer plate and its drawing. Select yes to update the table. And you can see that this is now shorter and the position, the two holes that were in the in here for the shoulder bolts are now removed. That is the completed changes from the die review.